Okay, so in this video, again, we continue with factorization of other general quadratics. We looked in the previous video ax squared plus bx plus c, but we looked at one restriction, which was for the situation where a was 1. So now we're going to move on and look at other situations where a is left to be any number. So basically it works out in a similar way. So some of the techniques are the same, which is we're still looking for two numbers that add up to give us b, and the product of d and e is going to be ac. But as you'll see, the situation changes a little bit. It's as to how what we do with these numbers. So let's start off with a straightforward example. In this example, we've got 3x squared plus 7x plus 4, and we've got basically, if we compare quickly our a here, okay, a is 3, b is 7, and c is 4. So that means what we're looking for is that when we add the two numbers, they should be equal to 7, and the two numbers, when they multiply, should be equal to 12. Very quickly, we see that the numbers are 4 and 3, positive 4 and positive 3. The sum of them is 7, and multiplied gives us 12. Now what you have to do in this particular instance is you have to basically do things slightly differently, and this is what the slightly differently part is going to be. So we're going to take the 3x squared, this essentially, and we're going to say, well, this, okay, so basically as we're doing here, so 3x squared plus 7x plus 4 actually becomes, or can be written as, just copy down the 3x squared. Now the 7x here that you see, 7x, okay, we can split that into 4x plus 3x. So basically, just going to put that on this. That's basically your 7x, okay? And plus, of course, you just copy down the 4. So this would be the traditional way of doing this particular question. Then, so next, just we don't see much common except the x here, so that leaves us with a 3x plus 4, and then plus 1 times 3x plus 4. So that essentially then boils down to just 3x plus 4 is now common into x plus 1. Okay. So what I've done here is basically, if you see the 3x plus 4 and the 3x plus 4 here is common. So I took them out, I took the whole bracket out as common, leaving an x here and the 1 here. So we end up with 3x plus 4 times x plus 1. Now that's the standard way of doing this. I have a shortcut of my own, so I'm going to show you the shortcut, and it's your choice whether you wish to use it or stick with this. It's completely your choice. So the shortcut works something like this. So actually ax squared plus bx plus c, and this will work for any a, b, and c, can be written as basically it's ax plus d, okay, multiplied by x plus c over d. Now you're going to ask me, what is this d? Well, it's the same as this d that we calculated here, so we're still using the same thing. So what it's saying is basically find the numbers, those magic numbers e and d and e before, and they remain the same, are 4 and 3. So what we'll do is, basically we're saying d is 4. Remember, d is always the larger of the two numbers. So that's one thing you have to keep in mind. D is the larger of the two numbers. And I mean larger in magnitude. Even if these are negative, you choose the larger in magnitude. So d is 4. Now if d is 4, this means, according to the little shortcut I have here, this should be, what is a in this case? Well, a is, of course, we've already identified that before. A is 3 in this case, so it's going to be 3x plus 4, okay, into x plus, what is c? C is 4, and divided by d, which is 4. And of course, that can be simplified to 3x plus 4 into x plus 1. And that is what we found before. But the question is, does it work consistently? So here's another example. 8x squared. Let's try it. 8x squared minus 6x plus 1. Now here, so a is equal to 8. Okay. B is minus 6. And C is 1. So this means that d plus e should equal minus 6, and d times e should equal 8. So that means the two numbers should have the same sign. We know that, which means both numbers will end up being negative. So if we proceed, which we will, this means the numbers to me look like 4 and 2. Actually, negative 4 and negative 2. Now, as I told you, as I advised you before, the number that's going to be d here is, we're going to use d equals negative 4 in our formula. Why? Because this number in size is bigger. So the magnitude of the number is the absolute value. So we will use d equals minus 4. Now if I use d equals minus 4, that means my factorization should be that. So let's clean that up a little bit. So we end up with 8x minus 4, okay, into x minus a quarter. Now there are various ways to simplify this if you don't like the fraction here, but it is correct. You can check. If I multiply these, I get 8x squared, okay, minus you'll get 2x, minus 4x is minus 6x, and then minus is plus, and it's just going to be 1. Now if you want, you can clean this up a little bit. If you notice here, there is a 4 that's common. So if you took the 4 out, 4, that'll leave you with 2x minus 1 here, and that'll leave you with a 4 multiplying x minus a quarter. Okay, so which would mean 2x minus 1 into 4x minus 1. That's another way of writing the same thing down. So you'll get this time 2x minus 1 into 4x minus 1. You can check yourself, of course. 2x times 4x is 8x squared, and minus 2x minus 4x minus 6x plus 1. So it's still correct. So this is it's a little bit shorter. That is, if you don't understand this splitting this is a typical way of doing it. I haven't seen this anywhere myself, but I'm sure somebody has done it, and you might find or already being doing it this way. But anyway, that's how that's one short way that you can do this. As an extra example, so if we were to just pick here, for instance, if I go down a little bit. Okay, so if I were to pick an example like this, which has x, I mean the a is 1 in this case, so x squared plus 7x plus 12, okay, remember in this case, if we were to do this, a is 1, like the previous video we saw, okay, and c is 12. So in this particular instance, the two numbers we get are 4 and 3. So what we would do is we would say, well, x squared plus 7x plus 12 is equal to, a is 1, so that's just going to be x plus 4, d is 4, remember, the bigger number, and then we have x plus c, which is 12, divided by d, which is 4. And you will see that the 4 and the 12, because they go into each other, you end up with x plus 3, which is correct, which is the factorization of this. So if you, all examples will work with the shortcut, and you have these options. This option is here. This one is, as I said, in my opinion, I haven't seen it anywhere. I mean, I just created it myself, but I am sure it is not unique, and you have seen this before. But I was trying to look for a way to shorten this and make it into just a formula, and this is what I found. But anyway, you are welcome to use this one as I said, if you find it easy. The only complication with this particular one comes up when, of course, here in this example, as you saw, when we got the x minus a quarter, and the 8x minus 4. It just happens to be that because there is a little 4 here that's common, you could bring that 4 into here and actually remove the fraction, and it just becomes 4x minus 1. So that's basically, I've done 2 examples of that, and I can tell you that all examples will work. And actually there's a third example that showed that the a could be anything back to 1 as well. All examples are covered under this. So hopefully that covers factorization of all possible quadratics. But one thing you must keep in mind, there's a caveat to that all quadratics, and that caveat is, or condition is, that you should be able to find the numbers d and e. Remember, there are quadratics that will give you complex roots, and there are also quadratics that will not factorize. So you cannot factorize them with whole numbers. You can factorize them with decimal point numbers. Thank you.